Good morning, children. So in the last class we were already started the discussion with respect to the chapter human reproduction. In that one we were already discussed about the structure of male reproductive system, and it includes the pair of tests along with the accessory ducts, glands and external genitalia, isn't it? And also we were discussed about the structure of female reproductive system, and also along with the pair of oviducts, ovaries, uterus, cervix, vagina, external genitalia. Also we were discussed about the structure of mammary glands, isn't it? Today we will continue the discussion with respect to the next topic, the gametogenesis. So now let us start the discussion with the meaning of gametogenesis. Now the question arises, what is gametogenesis? Okay, so let me to explain the process of formation of gametes in gonads. The gonads, that are also known as primary sex organs, is called gametogenesis. Let me do once again, the process of formation of gametes in gonads is called gametogenesis. It includes two types, namely spermatogenesis and oogenesis. So that means the types of the gametogenesis is of two types, the spermatogenesis and oogenesis. The spermatogenesis is found in males. In generally, we can also say the formation of the sperms, and oogenesis, the formation of ovum. Okay, so let us start the discussion. Today we will discuss about the spermatogenesis in detail. Okay, yeah. So as I said, the spermatogenesis, the process of formation of sperms, or we can also say the spermatozoa in seminiferous tubules of the testes, is called spermatogenesis. Okay, so one more question also they can ask, define spermatogenesis, like that the question they can ask, and then you should write the answer. What is spermatogenesis? The process of formation of sperms in the seminiferous tubules of the testes is called spermatogenesis. Okay, yeah. Then see, this whole process, the spermatogenesis, majorly it takes place in the three-step mechanism. Okay, so in textbook also you can just go through the diagram. I will also explain. Majorly there are three phases actually: the multiplication phase, the growth phase, and maturation phases it will come. Okay, but what it will be majorly includes the stages. Okay, the majorly there are two stages we can identify during spermatogenesis. That is nothing but the formation of spermatids, and the other process, the spermiogenesis. Okay, so in briefly we can say the formation of spermatids, they are nothing but the spermatogonia, that is nothing but sperm mother cells which produce spermatids. And what about the spermiogenesis? The spermatids transform into sperms. That is nothing but, the transform means nothing but, I will tell you in detail. So that is nothing but metamorphosis. Okay, yeah. So this is actually the two major steps. Okay, yes. Let us start the discussion in detail about the spermatogenesis. In examination they will also ask the major question, write the flow chart of the spermatogenesis, or they can also like the question like this, explain the spermatogenesis. Okay, so now if they ask the question like that, means you should write this flow chart neatly. Okay, and then after you should explain the steps also. So before we are going to the explanation, let me to tell you briefly. Okay, whatever the first two end cell which is indicates, that is nothing but the sperm mother cells. Okay, the sperm mother cell is the first two end, the indication of the cell. It is also known as spermatogonium. Okay, and it is derived, okay, earlier from the germinal epithelium cell actually. Okay, so that germinal epithelium cell which is undergo meiosis, and it will be gives rise to the sperm mother cell, that is nothing but spermatogonium. Okay, and from the here actually exactly the process will begin. Okay, and here the beginning of the multiplication phase, it will undergo, that is nothing but the mitosis. It will undergo the mitosis actually in the beginning. Okay, so it will be gives rise to the spermatogonia. That is nothing but whenever they undergo mitosis, it may be gives rise to many spermatogonia. Okay, now it will further enters into the growth phase. Okay, so in this growth phase we can identify the cell which is included, okay, which is highlighted in the orange color, right? So that cell is nothing but primary spermatocyte. Okay, and here you should remember the ploidy, that is nothing but chromosomal number is a 2n. Okay, after the formation of the primary spermatocyte, then it will move towards the meiosis. Okay, so this stage is nothing but the first meiotic division. Okay, now the 2n is get converted into n and n. Okay, so this phase is actually the maturation phase. Okay, so whenever it is undergo the first meiotic division, the primary spermatocyte, it will give rise to the secondary spermatocyte. Okay, it is given in the pink color. Observe the whatever they have given neatly. Okay, this flow chart is very useful to understand. And now when after the completion of this first meiotic division, which is continues the meiotic stage, now it will move towards the second meiotic division, okay, or the meiosis second. Okay, so finally there is a formation of spermatids. Okay, are you observing these green color structures? Then these spermatids undergo that is nothing but spermiogenesis. So the spermiogenesis is also known as metamorphosis. Okay, finally, so this spermatids is get converted into sperms. These sperms are also known as spermatozoa. Okay, are you getting? Yeah. Now let us discuss in detail. If they ask the question, you have to explain the three stages, right? What will happen? Once again, let me to explain briefly. As I said, it is a three-step mechanism. The first phase is nothing but multiplication phase, isn't it? How it will be beginning? The wall of each seminiferous tubule, okay, so consists of two types of the cells, namely gonial cells. It is also known as sperm mother cell, okay, and ceratolyzed cells. Are you observing? Then the gonial cells develops into the sperms, where the ceratolyzed cells are nourishing cells which nourish the gonial cells during spermatogenesis. Okay, this is how exactly the multiplication phase begins. Now, a diploid gonial cell divides repeatedly by mitosis to produce more number of spermatogonia. Okay, yes. So after this, it will enter into the growth phase, isn't it? Yeah. The growth phase, actually what happens during the growth phase, the spermatogonia increases their size due to the accumulation of nutritive materials in the cytoplasm, and the cells is ready to undergo meiosis. Okay, so this is also called primary spermatocytes. Okay, yeah, and remember this spermatocyte having 2n, that is 46 chromosomes. Finally, it will enter into the maturation phase. I hope you can identify in the structure of the seminiferous tubule also, tubule of the testis. So what is the final stage or the phase? Maturation phase. A diploid primary spermatocyte undergo meiosis to produce two haploid secondary spermatocytes which have only 23 chromosomes. Now the secondary spermatocyte undergoes second meiotic division to produce 4 haploid daughter cells called spermatids. And what it will be the ploidy of this number? So they are carrying only n, that is 23 chromosomes, isn't it? Yeah. The spermatids have to undergo further metamorphosis to convert into the sperm. So this process is called Spermatogenesis, or it is also known as spermatogenesis. Remember, they can ask this question also. Okay, yeah. So that means thus a primary spermatocyte, finally it will be used as how many number of sperms? 4 spermatids, or we can also say 4 sperms. Got it? Yes. And as I said, the spermiation, how it will be after the spermatogenesis, isn't it? The sperm head becomes, that means what it will be, metamorphosis, how it will be. The sperm head becomes embedded in the ceratolysis cells and are finally released from the seminiferous tubule by the process called spermiation. Okay, so you can observe the diagram which is given in the left side, the step-by-step mechanism, how that embedded the sperm head become embedded in the ceratolysis cells and finally released. I hope you can identify the structure, isn't it? Yeah. So now actually the process, okay, so the whole process, it is depends upon the hormonal, the secretion. So that we have to study the role of hormones in the spermatogenesis also, isn't it? Because without this hormonal secretion, there will be no spermatogenesis. For that purpose, so this can be asked in the examination also. Write briefly or explain the role of hormones in spermatogenesis, like they will ask the questions. Okay, yeah. So let me to explain. So this first of all, once again, what is the definition of this spermatogenesis? Means the transformation or differentiation. The transformation or differentiation, it is also known as metamorphosis, isn't it? So that transformation or differentiation of spermatids into spermatozoa or sperms is called spermatogenesis, and it occurs under the influence of FSH. And you know what is the meaning of spermiation? It is a process by which mature spermatids are released from the ceratolysis cells into the seminiferous tubule, isn't it? Now when it comes to the role, how it will be actually? Yeah, actually the spermatogenesis starts at the age of puberty. Okay, so due to the significant increase in the secretion or releasing of the gonadotropin hormone. Okay, it is also known as gonadotropin releasing hormone. Short formally we can also say GnRH. And this GnRH, which is a hypothalamic hormone, so that's what they have given in the slide in the first stage, hypothalamus. Okay, so these the GnRH or gonadotropin hormone, it is releases from the hypothalamus. Now the increased level of GnRH, that is the secretion of the GnRH, which leads to the acts on anterior pituitary. Okay. Then when it acts on the anterior pituitary, it leads to the stimulation. That means which stimulates the secretion of 2-gonadotrophin. Okay. So the whole process, it is just like last year we have studied the stimulus to response. Yeah. Now when this stimulates the secretion of 2-gonadotrophin, it leads to the secretion of 2 hormones, namely LH and FSH. The LH is nothing but luteinizing hormone and FSH is nothing but follicle stimulating hormone. Did you get it? Yes. So this LH actually which acts on leading cells, which stimulates synthesis of secretion of androgen, isn't it? Finally, so this androgen in turn stimulates the spermatogenesis. Okay. Now what about the FSH? So this FSH acts on serotonin cell and stimulates the secretion of some factors which helps in the spermatogenesis. And remember, this is all the chain. This is just like step-by-step mechanism. If any one stage, if there will be no releasing of, consider if there will be no gene RH, there will be no further process only. So this is all just like interlinked. Okay, interlinked. They are connected each other. Whenever that means releasing of gene RH, then only it acts on the anterior pituitary. Like that, they are nothing but it is a chain linked reaction. Okay, yeah. So this is exactly the role of the hormones in spermatogenesis we can identify. I hope you can identify. It's easily they were given, isn't it? Yeah. So after this one, we have to discuss about the structure of the sperm. We can also say the structure of spermatozoa. Okay, and you know what is the meaning of the sperm? Yeah, the sperm is a motile, movable. Due to the presence of tile, it can move. Then haploid, consisting of chromosome number N, and male gamete produced in the, where it is produced? It is produced in the seminiferous tubule of the testes, isn't it? Yeah, left side they were given the textbook diagram. Observe this one. Yes, actually, yeah, the sperm is about 50 to 60 micron, or we can also say 0.05 to 0.06 mm long. That means length, and it consists of majorly a neck. Okay, before that head is there. That means it consists of head, neck, a middle piece and tail, isn't it? I hope you can identify. A plasma membrane, and that means covers or envelopes whole body of the sperm. Can you identify? Yes. The sperm head contains an elongated haploid nucleus. The anterior part is covered by a cap-like structure is called acrosome. One mass question they can ask, what is acrosome? Okay, yeah. So actually acrosome is filled with enzyme that helps in fertilization of ovum. Okay, yeah. Yes. The head actually it is oval shaped, formed of the nucleus and acrosome. Acrosome is formed from the Golgi complex, contains lytic enzymes, because these lytic enzymes helps in the penetration of the egg or ovum. Then after that one, what it is present behind the head is a neck, isn't it? Yes, that means okay, neck is a next region. Immediately after the neck, what is present? The middle piece. The middle piece contains numerous mitochondria which supply energy. Last time we were discussed. Mitochondria is the powerhouse of the cell because which produces the energy, isn't it? Yeah. So here also the middle piece which contains numerous mitochondria which supply energy for the motility of the sperms, essential for fertilization. Yeah. So after this one, what it will be actually exactly? The middle piece, as I said, it is composed of axial filament surrounded by mitochondria and cytoplasm. Mitochondria which produces what is the requirement of energy? That energy which is required for the sperm motility. Okay. Yes. And the next region, what is the next region? The tail. The tail, it consists of a central axial filament. The extended region. The sperm moves in a semen or in a fluid medium, and the female genital tract by the undulating. Undulating means the tail is generally, I told you last year, it will move just front and back. So that is nothing but undulating movement. Okay, because of this undulating movement, immediately after the releasing of the sperms into the vaginal tract, they will quickly start moving towards the egg or ovum. Okay. Yes. And here there is a few interesting facts about this sperm in normal healthy human. Okay, a normal healthy human can ejaculate. That means he can release about 200 to 300 million sperms. You can imagine the huge number. 1 million is nothing but 10 lakhs, right? Like that, a normal human male can ejaculate about 200 to 300 million sperms during a coitus, of which for normal fertility at least 60% of the sperm must have normal size and shape. The remaining maybe not having normal size and shape. Okay, yeah. And out of these, at least 40% of them must show vigorous motility. So if they show all these characteristics, then only that person will be considered as healthy person. Okay, yeah. And if this, the sperms releases from the seminiferous tubule are transported by the axillary ducts, then the secretion of epididymis, I told you in the second and first class only, while we are discussing about the male reproductive system, the secretion of epididymis, then it will move towards the vas efferentia, that is nothing but the differences, then the seminal vesicles and prostate glands are essential for maturation and motility of the sperms, isn't it? Yes. And finally, the seminal plasma along with the sperms constitute the semen. I told you while we are discussing about the structure of the male reproductive system, the composition of the sperm also. The semen, isn't it? The semen is actually a slightly alkaline fluid. The pH is about 7.2 to 7.6, and it containing sperms and male reproductive axillary glands secretions that is produced by male during copulation, isn't it? The seminal plasma along with sperms constitute the semen. I hope you can remember. I told you in the beginning only, isn't it? Yes. And the function of male sex accessory ducts and glands are maintained by testicular hormones, that is nothing but androgen. Remember, sometimes in case of the infertility, some men, they may be facing the infertility problems. Of course, it's a rare, but nowadays it is because of modern life, the huge people, they are facing such type of problems. What may be the problem behind that one? If there will be no production of the androgen, the whole entire process will be not takes place. So due to the absence of the spermatogenesis only, there will be no releasing of the sperms, or sometimes that may be imbalancing. Okay, yeah, so let it be. So next class we will continue with respect to the oogenesis, isn't it? Thank you. Have a nice day.